All right, so a friend of mine is applying to be a hospital pharmacy technician, and she's asked me to help her through some of the problems. So these are some questions that she sent me. All right, the provider orders 2 grams IM times 1 dose of a drug. You're supplied with 1,000 milligrams per 2 ml vials. How many mils per dose will I administer? All right, Claudia, and whoever else is watching, again, the order is 2 grams once. We have 1,000 milligrams per 2 ml vials. This is the same thing as 1 gram per 2 ml vial. There are 1,000 milligrams and 1 gram. You gotta familiarize yourself with the metric system. So let's look here. None would be basically a gram. To the power of 3 would be a milligram. 10 to the power of 3 is 1,000. Same thing going the other way. Here we have a gram, and here to the power of 3 the other direction is a kilogram. 10 to the power of 3. So there are 1,000 grams and 1 kilogram. I would also know micro and nano. So there are 1,000 micrograms in a milligram and 1,000 nanograms in a microgram. They all go by powers of 3. These are some other common conversions I would memorize. This is from my NAPLEX prep book for my board exam. So a teaspoon is 5 mils, a tablespoon is 15 mils, a fluid ounce is about 30 mils. By weight, an ounce is 28.4 grams. A kilogram is 2.2 pounds. Back to our question. This is how I set things up. We need 2 grams, put it over X because we're not sure how many mils we need. That's what we're trying to figure out. And I set it equal to what we have, so 1 gram over 2 mils. Make sure the units match. On the top, we have grams, and on the bottom we have mils. And then this is called cross multiplication. So I multiply X times 1 and I get 1X, and I multiply 2 times 2 and I get 4. The units cancel out. So you basically have 4 equals 1X. So X would equal 4 mils. This is how you set things up. It's going to help you with more complicated questions. Say this was like 0.25X equals 4, something weird. You got to know how to set it up like this. Next question, how many milligrams are in 9.3 mils of 1/400 solution? So this is called a ratio strength. The concentration of a weak solution can be expressed as a ratio strength. It's denoted as 1 unit of solute contained in the total amount of the solution or mixture, example 1/500. Ratio strength is another way of presenting a percent strength. This is percent strength if you're interested. It can be percent weight and volume, or percent volume and volume, or percent weight and weight. So this would be grams per 100 mils, mils per 100 mils, or grams per 100 grams. This is interesting. In clinical practice, ratio strengths have been associated with medication errors. I wonder why, because I looked at that first problem as like, oh damn, I gotta bring out my book. The FDA now requires removal of ratio strengths from the labeling of injectable drug products. With only one active ingredient, for example, epinephrine or isoproterenol, ratio strength is still commonly used in compounding. So let's look at this one. Express 0.04% as a ratio strength. So we put that 0.04 over 100 and set it equal to 1 part over X part. Remember cross multiplication, 100 times 1, set it equal to 0.04 equals X. So basically 100 divided by 0.04, you're going to get 2,500. So that's how we get this ratio strength, 1 to 2,500. So in order to do this problem, I think we have to understand how to express it as a percent strength. So let's look at this one. 1/4,000, express that as a percent strength. So we set 1 part over 4,000 parts equal to X over 100. Again, we cross multiply and we get 0.025%. All right, so back to our question. How many milligrams are in 9.3 mils of a 1/400 solution? First, we're going to express it as a percent strength. So put 1 part over 400 parts and set it equal to X over 100. You cross multiply and you get 0.25%. This is weight per volume. Remember, we have grams over mils. Set up that percent as 0.25 grams over 100 mils. Set that equal to X grams over 9.3 mils. Again, these units have to match, grams at the top. We're trying to figure out how much of a drug is in this aliquot of liquid. You cross multiply and you get 0.02325 grams. Remember, they're asking for milligrams, so you have to multiply it by 1,000. You get 23.25 milligrams. Always check your units. Being off by a decimal place can kill someone. In our lab course in school, if we got like a question partially right, we would get points. But if our answer could kill someone, we would get no points, basically. This next question is another percent strength question. I'm gonna let you do that one on your own. Next question, prepare 25 milliliters of a 10 milligram per mil dexamethasone solution from a stock solution of dexamethasone 25 milligrams per mil and sterile water. How much concentrate and diluent are needed? All right, dilution and concentration. 0 and 100%. If the prescription calls for an ingredient that is pure, the concentration is 100%. The diluent does not contain any drugs, so the concentration of the diluent is 0%. This is important to know in general. We're going to use the formula C1V1 equals C2V2. Q is quantity. I like saying V for volume. Let's look at this problem as an example. A pharmacist has an order for parenteral nutrition that includes 550 milliliters of D70. The pharmacist checks the supplies and finds the closest strength he has available is D50. How many milliliters of D50 will provide an equivalent energy requirement? Remember, I don't know if you know this actually, but with TPNs, we use dextrose for carbohydrates. So V1, C1 equals V2, C2. Our first volume is 550 mils and our concentration is 70%. We're trying to figure out how much of the 50% dextrose we need. So 550 times 70% divided by 50% will give you that quantity. All right, back to our problem. Prepare 25 mils of 10 milligrams per mil dexamethasone solution from a stock solution of dexamethasone 25 milligrams per mil and sterile water. C1V1 equals C2V2. The stock solution concentration is 25 milligrams per mil. We have to figure out the volume. How much of this do we need? Set that equal to the second concentration that we're trying to prepare, 10 milligrams per mil. And our second volume is the final volume, 25 mils. So multiply 25 times 10 over 1, divide that by 25, and you get 10 mils. That's how much of this 25 per 1 mil dexamethasone stock solution you need. Remember, our final volume is 25 mils. So all you have to do is take 25 minus that volume of that stock solution, and the rest is going to be sterile water. We do C1V1 equals C2V2 with 2 concentrations. It's also important to know how to do an alligation. This is with 3 concentrations. Let's look at this example. A pharmacist is asked to prepare 80 grams of 12.5% ointment with 16 and 12% ointments that she has in stock. How many grams of the 16 and 12% ointment are required? This looks a little weird, but this is how you set it up. You put the concentration of the first ointment up here and the other one down here. You put your desired concentration in the middle, and then you subtract diagonally. So 16 minus 12.5 will give you 3.5. 12 minus 12.5 will give you 0.5. You drag across here at the top too, so 0.5 parts of this 16% and 3.5 parts of this 12%. Add the parts together, totally you have 4 parts, and then your desired is 12.5%. Remember, we're trying to prepare 80 grams of this 12.5%. So we have to figure out how many grams are in each part. So 80 is the total, divided by 4 parts would be 20 grams per part. We multiply that 20 by 0.5 parts, we get 10 grams of the 16% ointment. And then 20 grams per part again, multiply that by that 3.5 parts, and you get 70 grams of this 12% ointment. I don't know if you need to know how to do like osmolarity, isotonicity, and milliequivalent equations, but let me know. Let's do one last problem for flow rate and drip rate. A healthcare provider prescribes, this is actually an order, 1,500 mils of normal saline to be infused over 7 hours. The drop factor is 15 drops per mil. This is average, just depends on how viscous it is. The nurse should set the flow rate of the IV infusion pump at how many mils per hour and how many drops per minute. So here's our order. GTT means drop. First, let's do the flow rate. So 1,500 mils total divided by 7 hours will give you 214.28 mils per hour. Round that to 214 per hour. That's your flow rate. For the drip rate, it's a little bit more complicated. First, figure out how many minutes 7 hours is. It's 420. So we're doing 1,500 mils over 420 minutes. That's 3.57 mils per minute. Multiply that by your drop factor and you get 53.55 drops per minute. Remember, your units cancel out. That's how you keep track of things.